All right, welcome to Lab 2 Solved. In Lab 2, you are to write some logic to have a forward and reversing conveyor. It was also controlled by speed, such that you could confirm that the conveyor was running and that you could confirm it was up to the proper speed in order for the aggregate hopper to be open to put aggregate onto the conveyor. So I went through and again I created my header run with some information on it. Unfortunately the program will print it off when you do a printout, but the viewing of it isn't that great. Basically it just says this project operates an aggregate hopper, controls a bidirectional delivery conveyor, consists of 3 programs, with 2 of them provided by the conveyor vendor. It's run, speed, and speed switch. These programs are integrated such that the supply motor shaft monitoring procs. The switch determines the current speed of the conveyor once initiated. And again, I have a couple of minor spelling mistakes. Okay, so the first run looks like a normal stop-start. Now, it was not a part of the project, but I installed a e-stop circuit bit to allow for that, and it would be just like all the other devices that are normally closed and are being looked at to see if they're energized. We use the normally open contact. And just to remind those, when you look at the original way that we would program it, the instruction is actually called, this instruction here is actually called an XIC, which stands for execute if charged. So when we apply power, that contact has to be charged up for it to go. In other words, this e-stop has to be in its shelf state, which is normally closed, which passes power, which means that at that input of the card, it sees a voltage, and therefore it's charged and it's ready to go. So when the e-stop circuit is active, the stop button is not set, the motor overloads are not tripped. By pressing either the forward or reversing push buttons, the forward or reversing motor contactor shall close, and upon such closure shall initiate the run direction. And it's really difficult with this editor. They don't give you direction cannot be, mistake there, cannot be changed unless the conveyor is stopped, pressed, unless the conveyor push button, conveyor stop push button is pressed. Okay, so when the stop is fine and the stop button is not pressed and the motor loads are not tripped, those 3 conditions will stop the motor at any given time. And then we have a push button. When you push the push button in, it's looking to see that the other direction is not already engaged, and it closes the motor forward bool, which is an output. That output is then received in our speed switch control, and it will initiate the contactor. So it takes that time for that to scan through. You take that bit, take it to it, close the contact. That's our confirmation that the contactor is actually pulled in, and that will seal in that branch. Same goes with the reverse. If the reverse is energized first on that particular day, then it will disable the forward from being unless you hit the stop button first. Now around the stop push button, notice it's not the emergency stop circuit. It is the stop, some people will call it the system stop push button. When that is pressed, this conveyor dwell.q stays on as long as the motor loads aren't tripped. And if you hit the e-stop, it's not going to make any difference. So it's still being controlled. It's not that you cannot stop the motor, but it will allow it to run for a bit. We'll get to that in I think 1, 4, or 5. So Then the next rung says, okay, I've selected either forward or reverse. I'm going to start a warning horn. The next one says that when the warning horn is not finished, and yet it is timing our reg bit, then you're going to turn the horn on. And those two commands are going to have that horn run for 4.4¼ seconds. Then the next rung is where all the action takes place. So it's called the hopper gate control. So the hopper will only open if the conveyor is up to the proper speed and shall close if the e-stop circuit is deactivated. In other words, someone trips the e-stop. It will also close if the stop push button is pressed, or if the speed of the conveyor drops below optimum speed. Pressing the stop push button, that's shown there, now the e-stop controls the conveyor, the off delay conveyor. So it doesn't matter which direction it's going to go. If you press this stop button, these are going to drop out. And once that happens, our TOF, our conveyor queue, will then start to run. So the question then becomes, well, how do I actually get the conveyor running if I'm using this conveyor? Well, the contacts associated with it are located, that's that jumper that we have. So whatever direction you were going in is going to carry on, and it's going to count down 4¼ seconds. So once you've said, okay, hit the stop button, we're finished for the day, let it go for 4.25 seconds. The next program was the one that you were to import, and I elected to create a separate program for it, which is fine, you could have incorporated it, but I like to sometimes keep it separate so it's easier to see. And basically it's the exact same information that was provided on Slate. If the first one, I've named it procs stayed off, and its partner is procs stayed on. And basically these two are examining the status of the proximity switch, because if the signal stays the same for longer than 769 milliseconds, the conveyor hasn't moved. You may have told the motor to start, maybe you've got a broken linkage, maybe the belt is gone, whatever that prox is measuring, it hasn't seen a change of state, therefore it must be stopped. We take a look at the two of them, and if those two do not make within that 3 seconds and 76 milliseconds, then we turn on timer 4, and timer 4 then says, okay, I'm going to give you a conveyor at speed signal. Now the 769 milliseconds was found by taking 1 minute and dividing it by our 78 revolutions per minute. So it's a fraction of a second that's required for that to happen in a minute. You have 60 seconds in a minute, so you divide 60 by your 78, and you get a little less than 768, you get a little less than a second to make a complete revolution. So it's looking for that in each of these conditions, and when all of that's true, there is a confirmation. We have 4¼ seconds to give it time to get up to speed, and once that happens, when we haven't lost our ton 4, then we go ahead and say, okay, we're up to speed now, and we're going to keep that on and use that to control the speed. When we get onto our speed, this is again the program that we used before. There's our motor forward and motor reverse confirmation that we've pulled it in, and we have our time base for our running, and this is pretty much the same. Now you may notice that each of these is taking up a lot of room and you can't see, so I'm going to show you how we can fix that. You're going to take any one of these boxes and you're going to go to properties, and that's going to pull up the property box, and this is not giving me the one I want specifically. So I'm going to try this one, see if it gives it to me. Properties. No. Okay. So, right idea, wrong approach. If you put in a branch around any contact, highlight it, right click, property, it's going to give you the size of it. So the height is 25 and the cell width is 30. That cell width also applies to these other instructions. So we can't see what's going on, so I'm going to reduce that down to 20. And you notice that our instructions got skinnier at the same time. I'm going to close that, and now I can see the entire run. Sometimes it's difficult to read. I did not change, you'll notice, any of these because that was, we weren't supposed to touch that logic. It was supplied by the vendor. So they have the same ones, but that's basically, that's our conveyor running and the speed switch is working. So between the run speed and the speed switch, we confirm it and our program should work. So I'm going to put that back, and you can see how small these are. I get a lot more visual information. So I'm going to start download my program to the simulator. I have no build errors, yay. Alright, so when we first started up, I've got the start button, the stop button was made. Notice I'm still running because it was running beforehand. So we'll let that stop. It's all finished. Okay, good. Let's reset our stop. Nothing is confirmed. I'm going to press it in the forward direction, so our forward push button. And it's going to take a bit of a scan for that to become true. Once it becomes true, I can let go, and I'm running forward. My timer is doing the horn. The horn is now done, so I take away my done bit, turn the horn off. And down below we have our stop push button. We have the warning horn on. The conveyor is now at speed. We've had a chance for it to get up to speed, so we open up the gate valve. If I were to go in and somehow manipulate that speed, if you were actually using a true prox, physically using a prox, then it would trip up and see that it didn't see a change of state, and it would drop that and the gate valve would close. Now, I chose forward, and you can see that my forward auxiliary contact has started this off delay conveyor dwell. So it's now saying, well, I'm going to run, so I'm going to press and release my stop button. So the stop button is now off, and it's shutting down the system because it's waiting for that speed. And once the conveyor is no longer at speed, it even drops out the gate valve. So everything has done what it's supposed to do. I'm going to put that back on. Press my forward. I'm going to hit the stop button. We'll change directions here. We still have to let that time out. Okay, my conveyor ran as it's supposed to, so I'm going to change it, and I'm going to hit my reverse. And stop and seals that up. All closes up, and we now got our conveyor target or conveyor top ready to go. We're running at speed. I'm going to drop my stop again. So I have my switch. This is one of the problems with the simulator. You can leave things on and not notice it because you're not actually physically pushing a button. And the other thing that can happen is you're not clicking it quick enough and it doesn't change the state and report it fast enough, and it can be a little problematic. So I'm going to drop up my reverse, my timer, Q bit. The conveyor dwell was still on, and I ran out the reverse motor. And that's pretty much the how the lab was resolved.